Really? Right, so black is the cubic and the red one is the log 10 of the relative error of one step of a Halley method. The formula of which is shown here. But the computer doesn't have a problem with calculating it. And except that because I wanted the relative error, I did divide by x, but it's kind of nonsense because except when we are close to the root, or it is correct. If we are not close to the root, you could say Halley method is zooming in on the root. So if x is this, and then we apply one step of Halley's method, then we would end up, say, closer to the root. And the relative error is therefore the error divided by this value, not that value. And clearly I'm dividing by the input x value here, because you have this spike around x equals 0. So yeah, let's change this and divide by the result of the Halley step instead of by x. I think this is the red function here. Currently I'm dividing by the absolute value of x, but I should divide by the absolute value of the result that we get after applying Halley. Okay, so how do I get that value? Now, after assigning symbol x, you can evaluate something. I'm evaluating here the big formula, r squared. Okay, we need this value. This would be the error squared, and that's the error in xn plus 1. So you have to divide by xn plus 1. Okay, so I need that one and then evaluate it, I think. Which is equal to this one. Yeah, and that doesn't change because it's just symbolic. Okay, the square root, let's put that little factor over here. So I'm leaving out the epsilon, machine epsilon, and then graph the log 10 in machine epsilons. Since we hope, the best precision that you could theoretically possibly ever get is 1 machine epsilon. So this is always larger than 1. But yeah, the best that we could get is the log 10 of 1, which is 0. And my graph, the y-axis of my graph is from 0 till 2 at the top. So we get to see from 1 till 100 machine epsilons. The relative error. Now the spike around x equals 0 should be gone if it compiled. Oh, wait a minute, I can't evaluate that because it's not a symbolic expression. It's an FA. So I have to turn the FA into a symbolic expression first. How do we do that? Nobody knows what FA is. Text. That is a symbolic expression. I meant this one, floating point around of error expression. Expand, that's what we need. Expand turns it into a symbolic expression. Might as well do that already here then. I think, anyway. No, okay. So it's no longer no longer a spike at 0, because you're not dividing by the x value, but rather to where you jump to. There's an interesting spike here though, so apparently something is 0 here. Or rather, you would jump from here to somewhere, nobody knows where, unfortunately. Peculiar. Yeah, it doesn't really matter. I mean, even if you would start here with an incredible error, then it would still more or less get a lot closer. And then we have to deal with this error. So let's say this one jumps over here, which would be the most horrible place. It probably doesn't, but because the error here is still quite high. So then we get in the neighborhood of the root here, but with an horizontal error. But by that time it's just already constant, so inside the green line here. And the eventual error that we can't escape, because we don't keep jumping every step to the green line, is just this error. So you get the jitter with an amplitude of a little bit more than 10, I don't know, maybe 12 or something, times machine epsilon. And that is strangely not that big. So I wonder why it stopped here. There's again, there's some ball here. Why? Yeah. Okay, now I think that what it seems that the error is the floating point round-off error is inverse proportional to the derivative. So what about we just draw that in and see if it compares. So we take the derivative of this function and then we do 1 divided by that, and we draw that in as well, and then add on a logarithmic scale. And then hopefully we get something that matches this more or less. Or something. But then you have these 2 spikes downwards. Why? That is a bit strange. Okay, that would be nice if we could just don't want this. Well, actually, yeah. So I would have to copy the cubic. I think this one. And then do print roots. Print roots of this cubic. And that gives then the wrong thing again, where we divide by x. This doesn't change that much. Okay, let's fix it anyway. Let's do the same thing with print roots. So we're having something like xn plus 1, and I need to do this. There it is. Yeah, I think that's the duplication of what he does. Oh, there's another one here. What? Oh, it is just the one line. Okay, I think I get it. Yeah, maybe you can just fill that in. Same thing. If it exists, if expression xn plus 1 exists, then it must be the right thing. So just use that here instead of xn. Guess that worked. Yeah, no, the spike here is gone now. So now I have a spike here. Oh, that's the reason for this spike. This one. From this point we jump to 0, obviously. Yeah. So the spike from around 0 is moved here, because now we divide by the result. So if you apply Halley's method here, and then the next step, the next value of x is here, which means that the relative error in xn plus 1 is very big, because yeah, the error just doesn't change, but we divide by 0 suddenly here. So that's this thing here. Not very interesting, therefore. Unless, of course, the root is in 0 or very close to 0. That's definitely a special case. Yeah, what super irritates me is these artifacts, that it draws a lot of lines from the 0, 0 here in the corner. Don't want to see that. Why is that happening? I think it has to do with something becoming not a number, and then drawing anyway. So maybe you can suppress that. Just detected that one of the floating points, one of the floats or the doubles is not a number. Yeah, let's look for the code that draws these lines. So this is in print roots. And then I think this is not a quick graph. Quick graph is yeah, it's just the cubic in the arrow. So that's what we just looked at. Then there is another graph, which you can probably plot somewhere. This one, plot, yeah. So we're drawing to plot. No, we should be drawing to the layer of this plot. This is called second layer. Oh, probably also a plot. Yeah, create slider. Add Bezier filter. Sorry. I think this is using Bezier filter, which is kind of ridiculous, isn't it? I mean, it hardly looks like. It's not really a curve. You can't fit Beziers through it. It's just a blocky thing. Add a line, add another line, add another line, add another line. Another Bezier fitter. Dang. Yeah, I have several of those, of course. That is true. We have just 2 of them, so okay. Yeah, the Bezier filter is just not suited for that random thing. Okay, let's see, add Bezier fitter, what does it do? So we get all the Bezier curves. And then those are added. I could already do that not here. If the Bezier curve contains not a number of thingies. See how easy that is to detect. I'm in Bezier curves dus. The thing is just a matrix with a few numbers. We can look at that. You can just call B. That's still a vector though. Let's add a function to this vector to check if both coordinates are normal, I think. No, normal, not 0 is not normal, so that would be not work. Finite, maybe. I think standard finite is what I want here. I'm not super sure though. Is finite or finite? Is finite. Normal, subnormal or 0, but not infinite or none. Okay, I'll continue to do that. Just looking for none, but yeah, well, probably not a good idea to draw infinite coordinates as well. So we want standard is finite, so then I can simply add something called bool is finite. The Bezier curve.h apparently exists. Yeah, we already have it. Nothing. Almost expensive. And then now let's hope that was it. Yep. So these lines are gone. Pretty cool. pretty sure the green line was going through this point here. So why is it suddenly somewhere else? Strange. Yeah, can't be because of the change that I just made. Maybe it moved when I changed the not dividing by x by dividing by something else. Well, no, it should not have made a difference. Here's where I would look at my own stream. Hey, I can do that. Scroll back. Let's see if we go back and we get this. Edit stuff. No, well, before the edit it was also there. And then this. Yeah, here it is. Here it is going through this point. And then what change did I make after that? Yeah, that's weird. This is all the graph looks exactly the same, but the root is somewhere else. It's like just the green line is moved. That's the only thing that changed. Or is it? Now I'm doing another cubic. Oh, what the hell? Okay. Go back again here. It does not make any sense whatsoever. Oh, actually it does, yeah. So I can't show that, but I'm looking at my own stream from, I don't know, a while ago. And then the root was here. The difference is that I was using a different program. So the other program is drawing the line in a different position. That's not what we like. Now it's possible that there is a root here and a root there, and then we just switch from one root to the other root. Is theoretically possible. Yeah, the cubic has 3 roots. Okay, so that's the difference, I think. We have this one. Suppose it's now drawing this, and it used to be that one, and the other one is over here. Yep. Based on what does it pick the root? So I think these 3 spikes have to do with the 3 roots. So more or less spiking at the moment that we cross it, and then this one again, although you can't see that it goes through the top. And the other root is at 0.82, so maybe here. Yep, that would be that, maybe, probably, very likely. I could just draw all 3 roots, why not? I don't have a preference here for the root in this problem. I just draw all of them. So this is print roots. How did I choose one anyway? Green or lime? A root to double. Choosing root. Root is what? Imperial. It's just the first root that we find. Or not. What is this? It picks one of the smallest derivative. Oh yeah. Well, that would be that would totally explain why it is now the one in the middle, because that was higher. The error was higher, which is probably the inverse of the derivative, proportional with. But then I draw a line there, and then what do we do? Anything else with the dead root? Oh, that root is being picked for the other graph. Oh yeah, then it is important. At most, I could draw lines at the other roots as well, but then with a different color maybe. God, at least now I understand. So let's. I'm gonna leave it like this. Just picks another root based on that. This one looks specifically for the one with the smallest derivative. Yeah, let's make a graph in the quick graph, I guess. So this one, the QG. That draws the derivative for a start. Type add function. Okay, so just cubic there, and now we want to get the derivative of the cubic. Derivative. derivative. Should have given it a different color though. Very interesting. So it seems that these peaks, so this is the error, the logarithm of the relative error, right? And if you start at a point where the root is, then the error is large. We have 1, 2, 3 roots. The error is larger if the derivative is smaller in that root. But apparently the 2 points where we cross 0 itself, there is a dip. It seems to make sense to blow the thing a bit up, right? You can hardly see what happens here. So maybe I should not draw till 2.0, but let's draw till 0.2 even. So something like that. It would be very nice if I had multiple y-axes. Though, if I want to draw multiple functions. One of the ranges runs till 2 here, and then I use that as well for the logarithmic thing, which is kind of weird. They should have independent vertical axes. I wish I could, select something and then zoom in on that. And, I don't know, grab the whole graph and move it. Stuff like that. That would be pretty cool. Could make it so, but yeah. It's a little bit distracting from the real project. As if I ever care about that. Yeah, okay. Do want to blow this up though. That's the vertical axis of my quick graph thingy in print roots. So I'll make this 0.2. Let's make it a variable. Y range. Yeah, and I need to scale my log 10 thingy by this. How do I do that? Need a vector, just a vector, which means the, let's say the log 10 or the error. The max error or something. Y max error. I don't know where to put it. Double Y max error. Choose 2.5. Yeah, so this is the log 10 of maximum number of machine epsilons. The absolute is so max machine epsilons relative error. Which then means that I get my scale factor here. Scale random name. That is then y range dot I don't know, the larger one, max. Just max, obviously. Divided by the y max error. Can multiply with that would work. 10. It seemed to have worked. So now the top here is 2.5, but it's not visible here anymore. I just don't have that vertical scale. For the error, this is 2.5, and 0 is still 0. And this thing is now blown up because now it goes till 0.2, so now we can more clearly see. Well, the derivative is 0. This is the derivative. It's still not very visible where with roots and stuff. So let's blow it up another factor of 10. Why not? Factor of 20. Well, it can hardly be a coincidence, even though it is a total coincidence. I would say it goes down here completely related to the fact that we cross zero here, yeah. No, yeah, at least you can see the root here. And yes, that is the maximum here. I'm very, very, very sure that the error is proportional to the inverse of the derivative. It's a little bit more complicated apparently. So because of these dips here, I don't get them quite yet. And I want a different color for, let's change the cubic color to what? I should also more zoom in on this for this particular thing, I guess. Maybe just draw from a half till 1. Probably also Cairo window. Maybe we should just do using namespace Cairo window. Probably should do that. Yeah, have another color for my. Maybe something not that light. All the colors are too light. I want to use black for something else. Maybe blue violet. Got better start at the bottom. Otherwise it's in the way of my mouse. Turquoise maybe. Teal. Okay, I'm gonna do teal. Yes. Or not. Hmm. Yeah, it's. I have no clue. Well, I don't see it like this. But let's just draw something. Yeah, the function. I think I want to add. Let's compare it with the red one, so we have to use the logarithm of 10 as well. Skill, I don't know yet. And then I want to, well, probably I need an absolute value no matter what. And then let's say the derivative of the cubic squared. Minus minus a half times the cubic second derivative times the cubic in x. nothing. What the? Why not? Okay, I don't get it. Negative values. Pretty large negative values. Okay, so it's somewhere down here, but I forgot to take the inverse. Ta-da! Yeah. I need the inverse of this, so I can just put a minus sign in front of it then. Logarithmic of that. Okay, minus sign, but now we're too large, so now we need a scale. Let's say I want to see the 4 even still. What is the scale for this thing? Let's say 4 must become 0.01, so I need something like 0.01 divided by 4, something like this. There it is. Yeah, it's not super matching the red thing. I mean, I can scale it down, but then this crossing here never going to go away. Yeah, probably not super important, I guess. that enough? That just shifts us down 1. Oh, that's a bit much, isn't it? No, it was 2.5, so that's reasonable, actually. Or not. No, that's too much. Oh, this... never mind. The skill is outside the log. Yeah. Okay. I'll have to think about it again, I guess. I think it's very confusing that you can't see the axis of the logarithm. I don't know what 1 is even. Is this now the case that red and blue both go to 0? Very much to the left or the right, or not? No, of course they don't. Well, at least red is not doing that. 0 would be like in way too much precision. But blue should go to 0, I think. Because it is 1 divided by the derivative. And this black thing here, the parabola, is the derivative. So going very far to the left or the right means we are dealing with infinity. 1 divided by infinity is 0. And then the logarithm of that is, unfortunately, 1. Damn it. So the thing should go to 1, yeah. Should it? That's why I said I don't even know where the 1 is. Am I saying nonsense? No, I'm not saying nonsense. Yes, I am saying nonsense. That's minus infinity. A logarithm of 0 goes to very negative values. So blue should go down, 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 even till minus infinity eventually. Let's plot this again from minus 10 to plus 10. See what happens. Yes, it goes down. I think that what would be ultimately interesting is to have a Taylor expansion of the error function around the root. And then we just plot, say, the first order one of that. And then it should match exactly at the root, obviously. And then see how quickly it starts to divert. But no, not even that interesting, as long as the formula is simpler. I'm gonna have to give that some thought. Let's play some chess. I'll get back to it tomorrow, well, later this day, probably. I should go for a walk as well. This is like very long time ago since I did something in terms of exercise. Should go for a walk every day, but nah, not really happening, unfortunately. What's that queen doing in the center? Oh, that, yeah, I have to chase it away. Now the knight comes, come on, we all know it. But then I ignore that because my knight is already here. Okay, yeah, well, it looks like a good move. Chase away that queen. I want to go here, attack that point maybe, but the knight could go here, and then where do I go? So maybe I should do this one first, but it seems kind of silly with two undeveloped bishops. Maybe I should just first develop this one. That's also super weak. What's my long-term plan here? I have the center, so probably make it nothing. just develop castle and then start to push pawns forward on one side. Which side? Okay, this one. I could put my bishop here, but if then he plays this, just instantly not defended twice. Okay. I'm gonna do this anyway then. I can choose between going here or there. I like this though, so maybe I should just put it here instead of there. This is a bit far-fetched. If we go here, you could even put a bishop there or something. I mean, I haven't attacked that point at all. Okay, and then we go here. Get this castle. No, I could put my knight here and it is weakening the king side, pretty sure. But then I lose the tempo and it's not like I can take advantage of that. Of course I castle this side. I think this is more annoying. Plus it connects my rooks. So finally my opening is finished. Not a bad move. So that line is going to be opened. Oh no, let's put a rook there immediately. And then the other rook goes to the other open file. I wish I could push spawn, because I don't want this pawn to move, to go away. But it's 1, 2, and I'm short. Take, 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 and give check here after it takes with the knight. So push, take, I would have to take with the bishop, I just take. And then if the knight takes, I give check and I take, then yeah, I can push it. He has a 3 times defended, but this knight is overloaded in the sense that as soon as he moves the knight, I can check here, and then my rook participates as well. Yeah, but on the other hand, no, it's just those 3 pawns. Well, he can't push yet, but okay, then let's put this one away here or something. Now it's defended again twice, and I threatened to push it. Well, but for a very short time I threatened to push it. Okay, the other open file then. Guess I have to take it. This bishop is not attacked, well, this defended. I was planning to reroute over here, but then I lose a defender of my pawn. After the exchange on e1. Well, yeah, this thing is also attacked. It's already attacked 3 times. Now I can move my bishop away, I think. If it exchanges here, I take back with the king. Now we get that one. Well, I'm gonna try it anyway. I'm so running out of time here. No time left. Uh-oh. Yeah, now I'm losing on time. So this thing is coming and I lose that one. sure if that was good. Can take a pawn. Could take the pawn, pretty sure about that. No, he's coming in like crazy, so I have to exchange. But that's actually not that bad. Yeah, damn it. I should have. No, yeah, then this pawn would have come. Cutting off the king isn't that bad. Why is this not a draw? Bellevue can still mate. Okay, let's go for a walk. It's still even light outside.